We're going to expand your knowledge of identities to include addition and subtraction identities for the trigonometric functions that have a lot of utility. We're now going to prove the angle addition and subtraction formulas for sine. And we're going to focus on the addition formula that you see first, because that's the major proof we're going to use. In the alpha minus beta, the subtraction formula works the same way, just by switching the angles. So we're going to put that one aside and focus on proving the sine of alpha plus beta equals the cosine of alpha times the sine of beta plus the sine of alpha times the cosine of beta. And we're going to do that by creating this series of right triangles here, and we're focusing on what's the sine of this big angle here formed by CAB, triangle CAB, this big right triangle here, because that's formed with the angle alpha plus beta. And there's other right triangles of note here. Triangle FAE is a right triangle formed with angle alpha. Triangle EAB is a right triangle formed by angle beta. And there's also this other triangle up here, DEB, which is, why create all the right triangles? Well, that's going to allow us to use the trig ratios. And what we're really trying to do is prove that we can find the sine of this big triangle here, which is formed with a alpha plus beta. And the first thing we notice when we do that is that the sine of the big angle, alpha plus beta, is equal to the opposite, which is BC, over the hypotenuse. BC, this entire side here, forms the opposite. AB forms the hypotenuse. We've got to find some way to relate these into sines and cosines of alpha and beta themselves. So let's take this big side BC and break it up into parts BD and EF, which, since these two are parallel, EF is equal to CD. So therefore, this long opposite side BC is equal to BD, which is going to be involved in this triangle, plus EF, which is going to be involved in the light blue triangle. So knowing that BC equals BD plus EF, we can substitute that in for BC up here. The result is the sine of alpha plus beta equals BD plus EF divided by AB, because we just substituted BD plus EF up here for BC. Well, all those are related, but how do we get them in terms of parts of the right triangles that we need, and to get them into trigonometric ratios? Well, let's try to rewrite this. And hopefully you can see I can rewrite this fraction as BD over AB plus EF over AB. So we're getting a little closer to trigonometric ratios. But BD itself isn't going to help us much. So we're going to have to do something to this to get into trig ratios that we can use. Well, what if we could rewrite that first fraction, BD over AB, and multiply it by BE over BE, which is just 1, so it doesn't change it, and then rewrite it? We're going to get two trig ratios here, because BD over BE is a trig ratio of this small right triangle, and BE over AB is a trig ratio for this big pink triangle. So hopefully you can see that this fraction right here is the same as this first fraction here. Now I'm going to rewrite the second fraction similar. EF over AB, if I multiplied both the top and the bottom by AE, I'm going to be able to get two trig ratios that I can use. EF over AE is a trig ratio for alpha in the blue triangle. AE over AB is another trig ratio on the big pink triangle. So by multiplying both the top and the bottom by AE, I multiply it by 1, so I don't change it, but now it's all turned into trig ratios. So hopefully you can see that the second fraction here, by multiplying by AE over AE, is the same as the second fraction here. The difference now is, instead of some parts that I can't really use, I now have trig ratios. Trig ratios of three triangles: the blue triangle, the pink triangle, and then this other triangle here. So let's take these one by one. BD over BE is going to be a trig ratio, but we don't know these angles, or do we? Okay, now you got to really follow me here, because this work kind of gets tricky. If this is alpha, and DE and AF are parallel lines, which they are, then back from geometry, you have two parallel lines cut by a transversal. This transversal is AE. That means this angle alpha is the same as this angle alpha. You got to really follow me here. If this angle is alpha, because these are both alternate interior angles cut by a transversal, then we know this BEA is a right angle. Therefore, this angle plus this alpha equals 90 degrees. So this angle and this angle are complementary. This dark pink triangle, BED or DEB, is a right triangle. Since these two angles are complementary, and this is a right angle at D, this angle up at B, angle DBE, has to be angle alpha also. And if that's angle alpha, which it is because of parallel lines cut by transversal, and then using complementary angles, and knowing that this is a right triangle, knowing that all three of these angles are alpha, then this becomes the adjacent over the hypotenuse for angle alpha, the angle that's up here. Adjacent over hypotenuse is cosine. So therefore, BD over BE is the cosine of alpha. So BD over BE is the cosine of alpha. We're going to build this ratio by ratio. Well, the second ratio, BE over AB, is easier to see. BE and AB, BE is the opposite side of this large pink triangle. AB is the hypotenuse. Opposite over hypotenuse is sine. It's the sine of angle B, angle beta. So BE over AB is the sine of beta. So we've taken care of these first two terms. Let's work on the last two. Let's focus on EF over AE. EF is the opposite side. AE is the hypotenuse of the blue triangle. So that becomes opposite over hypotenuse, sine. EF over AE is the sine of alpha. EF over AE is the sine of alpha. The final ratio, AE over AB. Focus on the big pink right triangle. AE is the adjacent side, and AB is the hypotenuse of this triangle formed by angle beta. That is adjacent over hypotenuse, cosine. Therefore, AE over AB is the cosine of beta. And we've put all that together and found the addition formula for sine. The sine of alpha plus beta is equal to the cosine of alpha times the sine of beta, plus the sine of alpha times the cosine of beta. The subtraction formula can be gotten the same way if you make the big angle alpha and you make a smaller angle beta, and then this angle here becomes alpha minus beta. The only difference becomes the sign changes, and by sign I mean plus or minus. So it's taken quite a bit of work, but we have proven the angle addition and subtraction formulas for sine. The sine of alpha plus beta equals the cosine of alpha sine beta plus the sine of alpha times cosine of beta, and the sine of alpha minus beta equals the cosine of alpha times the sine of beta minus the sine of alpha times the cosine of beta.